The annals of naval warfare are defined by cycles of technological dominance, where a single innovation can render an entire doctrine obsolete. By mid-1943, the German U-boat fleet, which had once held the North Atlantic in a stranglehold during the First and Second Happy Times, was collapsing under the weight of Allied technological superiority. The Allied introduction of long-range air patrols equipped with centimetric radar, the perfection of the Huff-Duff high-frequency direction-finding system, and the relentless efficacy of coordinated hunter-killer groups had turned the predator into the prey. U-boat losses were spiraling to catastrophic levels, exceeding 30 boats a month, a rate the German industry could not sustain, much less replenish. It was within this desperate existential crisis that the German Naval Command, the Kriegsmarine, sought not merely an improvement, but a salvation. The Type XXI U-Boat, the Elektroboot. This was conceived as a weapon of technological revenge, a true submarine fundamentally designed to operate almost entirely submerged, effectively neutralizing the Allied advantages derived from air and surface radar. The vision was audacious, even utopian. The Type XXI would possess a dramatically streamlined hull profile, devoid of the clutter and external fittings that plagued older designs, allowing for unprecedented underwater speed. Its heart would be massive battery banks, possessing nearly 3 times the electrical storage capacity of the previous workhorse, the Type XXI U-Boat. This vast energy reserve would enable the XXI to sustain submerged speeds of up to 17 knots, a velocity faster than most contemporary Allied surface escorts could pursue. Furthermore, it was the first mass-produced submarine to incorporate the snorkel system, a retractable mast that allowed the boat to run its powerful diesel engines for battery charging while remaining submerged just below the surface, thus evading radar detection. The ambition was total: to restore the U-boat fleet's dominance and shatter the confidence of the Allied convoy system. The commitment of German industry to this project was absolute, fueled by the desperate belief that this technological leap was the only remaining path to victory. The resources poured into the Type XXI were astronomical, diverting capacity away from other crucial war efforts and cementing the project's status as a final, desperate gamble. The initial design specifications demanded a level of structural and mechanical precision that was, even under peacetime conditions, challenging. Under the relentless duress of Allied bombing, material shortages, and collapsing industrial coherence, these specifications became a silent, internal death sentence for the program. The Type XXI, therefore, emerged not as the operational savior Germany needed, but as a colossal logistical and industrial liability, a technological marvel doomed by the compromised quality of its own construction. The history of the Elektroboot is a chilling case study of how the most brilliant engineering concept can be utterly defeated by the collapse of the industrial base required to execute it. The true battle for the Type XXI was not fought in the Atlantic, but in the rushed, compromised, and structurally flawed assembly yards, where these technologically advanced machines began to fail before their journey even began. The ambition was justified. The execution was catastrophically flawed. The sheer technological complexity of the Type XXI demanded a complete overhaul of conventional submarine shipbuilding, leading to the adoption of a highly ambitious and ultimately flawed construction methodology championed by Albert Speer, the Reich Minister of Armaments and War Production. Recognizing the crippling effects of Allied bombing on centralized shipyards, Speer pushed for a system of sectional and modular construction. The rationale was elegant: decentralize the manufacturing. The submarine hull would be broken down into 8 large, standardized, prefabricated sections, with manufacturing dispersed across several hundred inland factories and assembly facilities, often utilizing non-traditional labor pools including foreign workers and prisoners. These massive multi-ton sections would then be transported by an intricate network of rail and barge to a handful of heavily fortified coastal assembly bunkers, where they would be rapidly welded together and launched. This system promised a breathtaking assembly time. The goal was to launch one Type XXI per week. The promise, however, ignored the prerequisite of industrial stability. Building a pressure hull requires adherence to almost zero tolerance for error, demanding perfectly consistent, high-grade materials and meticulously trained labor. The decentralized model shattered this prerequisite. The hundreds of dispersed factories, working under immense pressure and material scarcity, manufactured sections with incompatible tolerances. When these sections finally arrived at the coastal assembly yards, they often failed to align by several centimeters, necessitating weeks or months of arduous manual grinding, patching, and reshaping to force a fit. The very delay the modular system was intended to eliminate. The subsequent welding process presented an even graver challenge. The final hull required thousands of feet of high-pressure structural welds to join the prefabricated sections. These critical welds were often performed by hastily trained laborers, utilizing substandard welding rods and operating under continuous time pressure. The result was structural compromise. Porous, inconsistent welding seams that, under the crush of deep water, were structurally guaranteed to leak. When the completed hulls were subjected to mandatory, but often rushed, pressure tests, they catastrophically failed, confirming the massive structural insecurity. The initial promise of rapid assembly disintegrated into logistical chaos and engineering tragedy. The resources poured into this sprawling, failing industrial network, which included diverting capacity away from critical projects, were astronomical, cementing the project's status as one of the Third Reich's most costly strategic blunders. The Type XXI, a revolutionary design intended to dominate the oceans, was ultimately defeated by the microscopic failure of 1,000 compromised welds and the collapse of the industrial quality control necessary to hold its ambitious structure together. The resulting structural weakness restricted the operational depth and limited the very tactical advantage the massive battery banks were designed to provide. The true genius and the ultimate vulnerability of the Type XXI were inextricably linked to its revolutionary propulsion system centered on its vast, unprecedented battery banks. The Elektroboot was conceived as the first true submersible, designed to spend nearly all its operational life underwater. This required a power source capable of sustaining both rapid transit and prolonged patrol. The solution was the integration of 3 massive banks of lead-acid batteries, providing approximately 11,300 amp-hours, 3 times the capacity of the earlier Type XXI. This colossal energy reserve was the source of its legendary underwater speed, allowing the boat to achieve brief bursts of 17 knots when submerged, faster than many Allied surface escorts could travel. However, the sheer quantity of lead-acid batteries created critical, systemic safety hazards that were exacerbated by compromised wartime construction. Lead-acid batteries naturally generate hydrogen gas during charging and use. In a conventional U-boat, this was managed by frequent surface time and robust ventilation. In the Type XXI, designed for prolonged submergence, the risk was magnified. A ventilation system failure, common due to substandard component quality, would rapidly lead to explosive concentrations of hydrogen within the boat, creating a constant existential fire hazard. Furthermore, the immense battery banks were housed beneath the deck plates, making them highly susceptible to contact with seawater during a hull breach or a hydraulic system failure. The contact between seawater and lead-acid batteries initiates a catastrophic chemical reaction, releasing lethal quantities of chlorine gas, a poison capable of incapacitating and killing the entire crew in minutes. This secondary chemical threat transformed a minor structural breach into a potentially fatal chemical event, a fact often realized tragically in the compromised hulls sitting at the assembly docks. The vast and complex electrical network, with miles of wiring, intricate circuit breakers, and power management components, was also produced under compromised conditions. Faulty insulation and substandard circuit components further amplified the risk of electrical shorts and fires, which, combined with the omnipresent hydrogen risk, made the Type XXI a perpetual, internal threat to its own crew. The reliability issues extended to the advanced electric motors themselves. The boat utilized separate sets of motors, powerful main motors for high-speed evasion and quiet, slow-running creep motors for silent patrol. While the concept was sound, the production quality of the motor's bearings, cooling systems, and electrical windings often failed under stress, further compromising the boat's ability to operate reliably at critical moments. The complexity of the electrical and battery system was the source of the Type XXI's greatest power. But the compromised industrial execution ensured that this power source remained a perpetual, internal safety risk. The internal subsystems, designed to maximize the Type XXI's efficiency and submerged endurance, introduced a host of microscopic yet fatal flaws, particularly within the hydraulic network. The Type XXI was a vessel of unparalleled automation. Nearly every critical function, the hydroplanes, the large rudder, the torpedo tube doors, the rapid reloading mechanism, and the main external valves, was controlled by a vast, complex hydraulic system. This reliance on hydraulics demanded thousands of feet of high-pressure lines, high-precision valves, and, critically, thousands of specialized rubber seals and gaskets. Under normal conditions, this system would offer unmatched speed and control. Under wartime conditions, however, the system became the submarine's ultimate Achilles heel. The primary issue lay with the quality of the seals. Due to severe Allied blockades and material shortages, the production of synthetic rubber and specialized precision components was severely compromised. The rubber seals, manufactured with substandard materials, were prone to premature failure, cracking, and deterioration. Under the constant stress of high hydraulic pressure and the dynamic forces of the sea, a failed seal in an external valve meant a direct, high-pressure intrusion of seawater into the submarine, a situation that could quickly lead to catastrophic internal flooding, particularly if it occurred during a deep dive. Furthermore, the complexity of the hydraulic valves themselves, designed for precise, rapid response, meant that even microscopic debris or corrosion within the hydraulic fluid could cause them to seize or stick in a partially open position, compromising the integrity of the hull. Reports from the few operational boats confirmed that hydraulic leaks were a persistent, daily nuisance, requiring continuous, desperate maintenance by the crew simply to manage the internal pressure and prevent major flooding. The failure of the hydraulic system compounded the threat posed by the compromised battery banks. A structural breach caused by a failing hydraulic seal often led to the ingress of seawater into the battery compartment, triggering the immediate release of toxic chlorine gas. This chemical threat transformed a hydraulic leak, a maintenance issue, into a life-or-death emergency for the entire crew. The designer's ambition for automated efficiency was fundamentally undermined by the inability of the Third Reich's compromised industrial base to produce reliable rubber seals and precision hydraulic valves. The Type XXI was a machine of technological leaps, but its fate was sealed by the failure of the most basic, most vulnerable components, proving once again that in high-pressure environments, the failure of a single rubber gasket can be more lethal than the massed firepower of the enemy. The initial operational experience of the few Type XXI U-boats that managed to be launched was a continuous, demoralizing cycle of refit, repair, and failure, starkly illustrating the massive gap between the theoretical design and the compromised construction reality. The boats immediately proved too unreliable to be deployed into combat. The primary issues stemmed from the fundamental structural defects inherited from the rushed modular assembly process. Even after the initial catastrophic welding leaks were addressed, the hulls suffered from persistent microfractures and small structural weaknesses that became magnified under the stress of diving. This necessitated endless, time-consuming testing and patching at the assembly yards, consuming vast amounts of resources and effectively halting the promised mass deployment. Furthermore, the innovative systems, rather than simplifying operations, became persistent sources of failure. The advanced torpedo reloading system, a marvel of automation, proved finicky and prone to jamming in the rough, contaminated conditions of the assembly harbors, requiring frequent manual intervention and repair. The advanced sonar systems and passive hydrophones, critical to the submarine stealth mission, were unreliable, often generating spurious signals or failing entirely due to vibrations and component failure within the compromised hull structure. The crews, trained for perfection, quickly developed a deep-seated distrust of the boat's sophisticated automation, recognizing that the Type XXI was a collection of interdependent systems, all simultaneously prone to failure. The most immediate and terrifying operational restriction imposed on the Type XXI was its restricted diving depth. Due to the structural insecurity introduced by the compromised welding and materials, commanders were often forbidden from taking the Type XXI below safe, shallow depths. A submarine unable to dive deep loses its primary method of evasion and becomes highly vulnerable to conventional Allied ASW tactics. The vast battery power, designed to sustain deep evasion, was nullified by a compromised hull that dared not risk the pressure. This operational restriction alone rendered the revolutionary design incapable of fulfilling its strategic mandate. The few operational captains who attempted to take the Type XXI on brief, limited training cruises constantly battled internal leaks, hydraulic failures, and electrical faults. The high maintenance hours required to keep the boat running often exceeded the hours it spent actually training, cementing its reputation among the crews as a complex, unreliable liability. The operational verdict was clear long before the war ended. The Type XXI, while a brilliant concept, was a failed platform, a testament to the fact that revolutionary design cannot compensate for the degradation of industrial quality and systemic material failure. The strategic failure of the Type XXI program exerted a massive, distorting influence on the entire German war economy during its final, desperate years. The sheer scale of the resources poured into the Phantom fleet was immense, diverting critical material, labor, and infrastructure capacity away from more viable and immediate defensive war efforts. The investment was not merely financial. The Type XXI consumed tons of specialized, high-grade steel, complex electrical components, and thousands of skilled laborers, resources desperately needed for fighter defense, essential rail maintenance, and conventional infantry supplies. The project became a sinkhole, consuming national capacity without ever producing a single combat-effective unit. The political desperation surrounding the project only amplified the catastrophe. German High Command, continuously pressing for the mass deployment of the Type XXI, ignored the increasingly dire reports of structural failure and production delays. This political pressure fueled the continuation of the compromised modular construction system long after its fundamental flaws had been proven, locking the German industry into a cycle of wasteful rework and ineffective production. The deployment of the Type XXI was meant to be the psychological and technological counterpunch that restored morale. Its highly publicized potential, the Elektroboot myth, was used extensively in propaganda to reassure the German public and the weary U-boat crews that victory was still technologically attainable. The operational failure of the fleet, therefore, delivered a secondary psychological blow when the mass deployment failed to materialize, further damaging the credibility of the military leadership. The ultimate paradox of the Type XXI remains its enduring technological legacy despite its operational failure. While the German Navy failed to utilize the design, the concepts proved instantly indispensable to the victorious Allies. The captured hulls, blueprints, and engineering talent became the foundational basis for the post-war submarine fleets of the United States and the Soviet Union. The influence of the Type XXI's streamlined hull, Massive battery banks and focus on submerged speed propelled naval technology forward by decades. The project, designed to secure the German future, ultimately armed its enemies during the impending Cold War. The Type XXI stands as a chilling testament to strategic resource mismanagement, a spectacular failure that consumed vast resources, but whose intellectual property ultimately defined the next generation of naval warfare worldwide. The most dramatic and conclusive demonstrations of the Type XXI's fundamental flaws were the numerous instances of the U-boats suffering internal flooding and catastrophic damage while moored or under construction, the submarine that truly did sink its own base. These dockside failures were not victims of Allied sabotage or enemy action. They were the consequence of the compromised quality of construction and material failure. The persistent hydraulic leaks, stemming from substandard rubber seals and valves, often led to sustained, uncontrolled ingress of seawater into crucial internal compartments. The ultimate tragedy occurred when these floods inevitably reached the massive lead-acid battery banks. The chemical reaction between the seawater and the lead-acid components instantly released massive, lethal clouds of chlorine gas throughout the interior of the confined vessel. A structural breach, a fixable mechanical problem, was instantly escalated into a chemical life-or-death emergency, requiring the immediate, costly evacuation and decontamination of the entire submarine. In several documented cases, the flooding was so rapid or the chlorine concentration so severe that the submarine had to be abandoned and sank right at the pier or inside its assembly bunker, a profound symbol of the technological failure. These dockside sinkings provided undeniable physical proof that the Type XXI was inherently flawed and unsafe. The constant, predictable internal failures further eroded the confidence of the shipyard workers and the submarine crews. The maintenance hours required to manage the endemic leaks and electrical faults were astronomical, consuming more time and resource capacity than the entire project could justify. The political pressure to meet launch quotas often forced the Kriegsmarine to accept delivery of incomplete or structurally suspect boats, merely passing the liability from the builder to the operating command. This political necessity led to the absurd situation where dozens of Type XXI U-boats, although nominally completed, were not fit for combat and remained confined to harbors, undergoing continuous repair and refit, transforming them into stationary resource sinks. The dockside sinkings remain the most potent symbol of the Type XXI's failure. A revolutionary vessel designed to conquer the deep was defeated by the microscopic failure of a rubber seal and the integrity of its own industrial origin. The final days of the war saw a frantic, highly secretive effort by the German military to either scuttle the remaining Type XXI fleet or attempt to salvage and utilize the valuable technological assets before they fell into Allied hands. As Allied ground forces closed in on the coastal assembly yards and inland factories, orders were given to destroy the most complete U-boats to prevent their capture. However, Allied intelligence was fully aware of the technological significance of the Elektroboot. Highly specialized intelligence teams, the T-forces, were rapidly deployed with the specific mission of seizing and studying the Type XXI's hulls, blueprints, and crucially, the engineering talent responsible for the design. The ensuing scramble led to the capture of dozens of incomplete and severely damaged Type XXI hulls. The most valuable prizes were the handful of almost complete vessels, including the U-2511 and U-3017, which had achieved limited operational status. These vessels were immediately secured and transported under immense secrecy to Allied naval bases in Britain and the United States for meticulous study. The information gained from these captured assets was overwhelming. Allied engineers were astonished by the advanced design concepts. The streamlined hull, the massive battery configuration, the quiet electric motors, and the hydraulic systems. The Type XXI, despite its operational failures, was confirmed to be decades ahead of Western submarine design. The insights gained from the captured U-boats were instrumental in shaping the next generation of U.S. and British submarine development, particularly the streamlining and large battery capacity concepts. The irony remains profound. The German Navy failed to successfully utilize the design, yet the very concepts that defined its failure in the 1940s became the globally accepted blueprint for submarine warfare in the 1950s and beyond, immediately accelerating the technological arms race of the Cold War. The lasting influence of the Type XXI U-Boat is most clearly observed in the immediate post-war naval programs of the Soviet Union and the United States. Both superpowers launched intense, competitive efforts to reverse engineer and adapt the captured German technology, recognizing that the Type XXI was the foundational blueprint for modern submarine warfare. The U.S. Navy initiated Operation Seafoam to recover and study the captured U-boats. The subsequent Guppy, Greater Underwater Propulsion Power Conversion Program, which streamlined existing U.S. fleet submarines and installed larger battery banks, was a direct, explicit adaptation of the Type XXI concept. Later U.S. submarine classes, including the Tang and Barbell classes of the 1950s, incorporated the Emperor's streamlined hull and advanced electromotor configurations, establishing the United States' commitment to the true submarine doctrine. The Soviet Union was equally aggressive, launching its own program to replicate the captured technology. The Soviet Whiskey-class submarines, which were built in massive numbers during the 1950s, were heavily influenced by the Type XXI's hull shape and internal layout. The Type XXI, therefore, initiated a technological transfer of unprecedented scale, dictating the terms of the Cold War's naval arms race. The failure of the Type XXI was a strategic loss for Nazi Germany, but its capture became a windfall for the emerging superpowers. The submarine designed to secure the German future ultimately provided the foundational technology that armed its enemies during the critical early years of the Cold War. The Type XXI stands as a testament to the fact that scientific value transcends political collapse. The final after-action report on the Type XXI U-boat offers a definitive, complex verdict. The Type XXI was not a failure of engineering vision, but a victim of industrial collapse and bureaucratic overreach. Its core concept, the high-speed, long-endurance submerged vessel, was fundamentally sound and proved to be the future of submarine warfare. Its fatal flaw was the degradation of material quality and the impossibility of maintaining the required precision under the immense pressure of the war's final years. The consequence was systemic failure. Porous welds, compromised hydraulics, and restricted operational depth that rendered the fleet ineffective before launch. The ultimate paradox of the Type XXI is that its military failure was a direct catalyst for post-war naval triumph. Its capture immediately accelerated the technological development of both the Soviet and American fleets, dictating the design standards for the next generation of submarines. The Elektroboot, though unable to win its own war, ultimately established the blueprint for the modern submarine, transforming naval strategy worldwide. The story of the Type XXI is a critical, enduring lesson in strategic resource management. It demonstrates that the most brilliant and advanced technology is only as strong as its weakest weld and the quality of the industrial base that produces it. The failure of the XXI is a chilling testament to the fact that genius cannot compensate for fundamental material compromise. This is the final, undeniable conclusion of the after-action report.